Hi there, welcome to this tutorial where we will look at various Java interview questions asked for the experienced. In the previous video, the link of which you should find below, we discussed about what are the important interview questions for freshers, like platform independence and differences between C++ and Java and the basics of object-oriented programming and those kind of stuff. We looked at what are the advantages of OOPS and stuff like that. So in this tutorial, we'll look at what are the important interview questions which are asked for the experienced people. So the various topics that we would be looking at are what we would see on the screen right now. Coupling, cohesion, what is an inner class, constructors, and what is constructor chaining, and what do you mean by copy constructor, and how do you use asserts, what is reflection, and the favorite topics of interviewers, collections, serialization, and also a little bit of about exception handling and threads. So these are the various topics that I would like to cover the interview questions of in this particular video. So let's get started. Let's start with the first topic that we want to discuss, which is coupling and cohesion. What is coupling? I mean, what really is coupling, and why is coupling important? That's the first question that we would discuss now. So let's look at a small example piece of code. So here I have three inner classes defined. One is, this is a typical shopping cart application that we would have seen a number of times. We have a shopping cart entry. That particular, like for example, I have a shopping cart with a bottle of milk and probably some sugar. Then for each of the entries you'd create an object of this class. So I would have probably 5 quantities of what price. So I have 5 milk and the price of milk is 10, and probably I have one bag of sugar and the price is 15. So for each of those a shopping cart entry is created. The shopping cart holds all the list of items which are already in the shopping cart. So and you have the order class which is actually doing the calculation of the order total price. So when I want to calculate the total price that a customer has to pay, I use this order total price. If you look at this order total price, it actually is doing a lot of things. First thing it's doing is it's actually multiplying the price and quantity. So because I have 5 things and price is 10, so 5 into 10, 50 is the total price, and it's adding that for all the things in the cart. And also you would see that it's calculating the sales tax. So if we look at these particular classes, these are tightly coupled, because if let's say I change the name of the price, if I change the name here from price to something else like price 1, or there's some internal change which is done to this class, then this class also gets affected. So this price, how it's done, would get affected. Also, if there is a change in, let's say right now this is an array. Instead of using an array, I want to use an array list here. So in the shopping cart right now we are using an array to represent the items, but let's say at a later point in time I would want to use an array list to do things in the shopping cart. Then this thing would not work, because the way I would, like, cart.items.length is array specific. So this would have to change. So this method actually knows a lot of things about the cart item, shopping cart entry, and the shopping cart, and that's not really good design. In a good design, a class should not know a lot about the other class. I mean, a class should not call should not know the internal details of another class, and that is what a coupling is measure of. Coupling measures how much does a class change when the other class changes. So if I change something in this shopping cart entry, how much does this order class gets affected? If I say change this items from an array to array list, does it impact any other class, or is the impact only in this particular class? That is really what coupling measures. Coupling measures how much a class is dependent on other classes. There should be minimum dependencies between the classes. One class should not be dependent on the other classes. It should be self-contained. And whenever something changes in the class, it should not affect anything else in the other classes. Now let's look at the solution for the same problem. Let's see. So if we look at the solution, you'd see that we have added in a method called getTotalPrice. So at the end, what we want from the shopping cart entry is what is the total price for that particular thing. So I created a method called getTotalPrice, and it returns price multiplied by quantity. And also in the cart contents, we have created another method, getTotalPrice. What it does is it loops through the items, and it calls the method which we created in the item class. So it calls the method which is created in the item class, in the shopping cart entry class, and it sums it up. So if now instead of this being items being an array, if let's say it's now I'm changing this to list of, okay, I should have done it the other way around. Oops. So it's list of shopping cart entry items. So oops, let's resolve the inputs. So you'd see, even though I'm changing from array to array list, the rest of the code doesn't get affected at all. So now I can go back to what it was, shopping cart entry, and we've created a method called getTotalPrice, which returns the total price, and we have created a class called order, which actually just calls the total price on the cart and adds the sales tax to it. So it calculates. So that's basically, so the responsibilities from between the classes are clearly divided. So order class, all it's responsible for is calculating the sales tax. So it takes the shopping cart amount and adds the sales tax to it. The cart contents, that's basically the total shopping cart thing, calculates the shopping, like does the totaling of all the prices for the items. It does not calculate the value for the item. That is done by the shopping cart entry class itself. So now if I change, let's say I'm changing this thing, and I want to change from price to price 1, or whatever you'd want to change, you'd see that the rest of the classes don't get affected at all. This is what is called coupling. So coupling is a measure of how much classes are dependent on each other, and we would want to have as minimum coupling as possible between the classes. If you have maximum more coupling, it means when I make a change in one class, it would affect the other class, and that is not really what we want when we are doing any programming. So coupling is like one of the important things. The next important question that we would discuss about now is, what is cohesion? Like, I mean, like coupling and cohesion are almost used together. So now let's look at what is cohesion, and let's look at an example for cohesion. So to start off, cohesion is actually a measure of how related the responsibilities of the class are. Okay, sounds very technical. Let's just get started and try and make sense of it. Let's say I'm writing a sample program. I would want to download and store. So basically I'm writing a small program. The program downloads something from the internet, and then let's say I'm calling a website. I'll get the content from the website, parse it, and then store it into the database. So there are three things I'm doing. I want to go to a website, get all the content from it, get all the HTML content from it, and I want to store the content back into the database. So the way this class is doing it right now is it's having three methods called download from internet, parse data, and store into database. And everything is done as part of this particular class itself. So if you look at this particular class, it has a lot of responsibilities. It needs to know how to do a HTTP call, get the content back, and it needs to know how to parse the data. Probably some kind of an XML parsing or HTML parsing should be present in here, and it should also have some kind of a JDBC or Spring DAO or something of that kind to store it into the database. So if you look at this particular class, it has a lot of responsibilities, and this particular class can change if any of these responsibilities change. So we'll now look at the ideal way how it should have been implemented. So the ideal way to implement this is to have separate classes for each of those responsibilities. So the class internet downloader takes care of downloading from the internet. So it knows how to go to a particular URL, get the information back, and return it back. And the data parser knows has the responsibility of parsing the data. So it gets some data. You can give some data to it, and it can understand it and put that into a structure that we can understand. So it can get the information in XML format and convert it and put it in a Java class. And the next one is the database storer, which actually knows, once I give it a Java class to it, it knows how to store it to the database, which table to put it in, what is a query that needs to be used, or it's using some kind of a JPA. So it uses those kind of things to put it into the database. So if you look at the class right now, it's this particular class download and store is only responsible for invoking the method. So it creates a new instance of the internet downloader and does the download, and then it does a new instance of parser and parses the data and then stores it into the database. So if you look at this particular solution, you'd see that the responsibilities are divided between the classes. So different classes have different responsibilities. Different classes have their own responsibilities. And when I want to change something about how I am downloading from the internet, the only thing which gets affected is the internet downloader class. The other classes don't get affected at all. And this is what cohesion is. Cohesion is a measure of how close the responsibilities of a particular class are. In this particular class, now this is only responsible for downloading from the internet. However, in the earlier example, if we look at it, this particular class was responsible for 4 or 5 other things. So that's that's the end of next question. That's basically what is cohesion. And now that we know what coupling and cohesion is, I think it's very easy to talk about what are the differences between coupling and cohesion. Now let's look at the next topic, which is inner class. Inner class also is a very favorite question. So the first important thing about an inner class is that inner classes should be used as less as possible. Like inner classes should be avoided if it's possible to avoid it. So if you have it's ideal to have a class outside, on its own. Inner class is only used when you want to have a class available in the restricted scope inside another class. So like the first piece of advice is avoid inner classes as much as possible. If we look at this particular thing, this example shows all the different kinds of inner classes that you can have. So if you look at this particular thing, this is an inner class which is created inside a method. So the example method is a method, and we are creating an inner class inside the method. And obviously, once I have created an inner class within a method, the inner class in the method can be used only inside that particular method. This is not really ideal. Having an inner class inside a method is not something that we do frequently. But this kind of inner classes we do use. So if we look at this particular inner class. This is we have an outer class inside which we are defining another class, which is called public class inner class, and you'd see that we have a inner class variable. So inner class can have member variables of their own, and you can see that we can also create a few methods in there. And if you look at what are the things that are available inside the methods of an inner class, all the variables of the outer class. So the outer class variables are also directly present in the inner class. So this was an outer class variable in the sense that it's declared here in the outer class, and we are making use of it in the inner class in here. So in this inner class, we are trying to set a value to it. So in the inner class, you can access the outer class variables and also modify them. And also you have a reference to the inner class. However, if you want to reference the outer class from the inner class, you have to use the name of the outer class. I mean, the name of this particular outer class that we created is outer class itself. So I do outer class dot this. So yeah, so basically an inner class is a class which is defined in another class. Here, if we look at this, we have a class called outer class, and inside that we created this class called inner class. This is basically an inner class. There are different kinds of inner classes. Like this is a normal inner class. There's also a static nested class. So this is when we declare a class as static, then it is called a static nested class. So this is a static inner class. When we see the static inner classes, the most important thing is the static keyword. However, in a static nested class, the instance variables of the outer classes are not available. So there is, I mean, as we know with static, anything that is static, there is only one instance of that. I mean, you cannot create an instance of that particular class. There is only one instance of that particular class present. So obviously it cannot access the private instance variables of the outer class. So if there is an instance variable in the outer class, you would not be able to access it. So if from this class, if I'm trying to access the outer class instance variable, it gives me a compilation error. So that's the inner classes. So basically, an inner class is a class in another class, and there are two kinds of inner classes. One is the normal inner class, and the other one is the static inner class. And in the static inner classes, you will not be able to access the instance variables of the containing class, the outer class. So that's basically the important things that you need to know about a inner class. But the most important thing about an inner class is that try to avoid it as much as possible, unless you cannot solve a problem without using inner class. Let's move on to the next one, which is constructors. So let's talk about constructor chaining. If you want to really look into constructors into detail, you can use the video link which is right beside. But in this particular interview questions video, let's discuss about two important topics on constructors: what is constructors chaining and what is copy constructor. So let's move on to constructor chaining. So basically, when we talk about constructor chaining, the important concept which comes in is inheritance. I have a chain of classes which I defined. So here I have a class named superclass which has a variable named name, and I also have another subclass which is extending this superclass, and it has a member variable called value. So if you look, this superclass has one constructor to accept the name. So it accepts the name and sets the name to the sets the whatever values passed to the name variable. And the subclass, it is having a constructor which accepts the name of the superclass. So the name of the superclass and the value. So if you see, the value is present in the subclass. So this subclass if he wants to set the name of the like this name variable, then it calls the superclass passing the name as an argument. So if you look at this subclass constructor is calling the superclass constructor. So it's calling the super. If you look at it, it takes me here. So this subclass constructor is calling the superclass constructor, passing this variable to it, and that is what is called chaining. So chaining is basically, constructor chaining is basically from the subclass you can call the superclass constructor. So in the subclass I'm calling the superclass constructor with a name. Actually, if I don't make this call, then what you'd see that there's an error coming up, because it implicitly call something called super. So if I don't make a call, it does this, and you'd see that there is no constructor defined. And if I do public superclass, public superclass, and this, the code compiles, because the constructor chaining class is implicit. So if I don't do super of name, I mean, if I don't call the superclass constructor, a subclass constructor automatically calls the superclass constructor. So in that sense, actually, chaining automatically happens whenever you create a subclass. So whenever we create a subclass, the superclass constructor is automatically called. So that's almost called default, like the default thing which happens. But usually we refer to constructor chaining to explicitly calling it. So here I'm explicitly calling the superclass constructor using the keyword super. Super is the keyword, and I'm calling it passing the argument name. So this is basically what is called constructor chaining. So that's constructor chaining. And now let's discuss about what a copy constructor is. So copy constructor is normally used when I want to copy a complete instance of one object. So I have a student object. I mean, I have an object of class student, and I want to make one more copy of the same class. So in those kind of situations, we use something which is called a copy constructor. It's almost very similar to cloning. I mean, because you get another instance of the same class, but in cloning you cannot really control what is copied and what is not copied. So copy constructor can allow you to decide you want to copy certain values and you don't want to copy certain other values. So copy constructor is nothing but it's very similar to a normal constructor. So this student constructor is accepting name as a parameter and marks as parameter. However, this particular constructor, if you see, accepts the same class itself as a parameter. So this particular constructor is accepting, this is the constructor of the student class, right? And it's accepting another student class as a parameter, and it takes the name values and the marks and sets it into it. So this is basically what we call a copy constructor. Copy constructor is a constructor of the same class accepting the same class as a parameter. And you can see now that I can actually, if I say student of Ritu 100, and I'm to create a copy of this student using the copy constructor, I do new student of student. So this is an instance of the student, right? This is basically instance of the student class, student instance. So I've created an instance of this student class and passing that student instance to the constructor to create another copy. If you change the value of student in this student instance to something else, the student copy does not change, because this student copy is a different class on its, I mean, different object, different complete object instance on its own. So that's basically the copy constructor. It's basically a copy constructor is a constructor which accepts the same class as a parameter, and it helps you to create a new object of that particular class with customization. You can, I mean, let's say I don't want to copy the marks, I just want to copy the name or something of that kind. So those kind of things are possible. I mean, it's, if there are 100 variables, I just want to copy 50 member variables, then I can use a copy constructor. It's very similar to cloning. I mean, the end result is very similar to cloning an object. The next thing that we will look at is asserts. So asserts is a concept which was introduced in Java 1.4. It's basically a way to check when a method is called whether a certain constraints are met. So let's say I have a shopping cart class or some method in the shopping cart. I want to always make sure that the quantity of items is at least 1. So if the quantity items is -1 or -2, I don't want to even go into the method. And it's not really a exception handling because I don't really expect that method to get -1 or -2, or I expect it to be always called with 0 or 1, but I just want to be safe. And in that kind of scenarios, I use assert. Assert is not really for negative scenarios. I mean, if let's say a user enters a value on the screen -2 and you are validating it, in those kind of situations, you should not use asserts. Asserts in those kind of scenarios, we should use exception handling because you -2 is a value that you expect and user is entering a wrong value, then you should tell the user back that you are doing something wrong. Asserts are more used in scenarios where you don't really expect that to happen at all. So you're talking to some other system and let's say -2 is a value that you don't really expect from that particular system. In those kind of situations, you can put an assert to just safeguard. So the most important thing about asserts is asserts, when an assert error is thrown, the entire you will not be able to handle it at all. It would just it would just completely go out of the complete class. So it's better to use asserts only in scenarios which you don't expect at all. So that's the first thing about asserts. It basically enable you to validate assumptions, and if an assert fails, it throws something called an assertion error. Let's just look at a small assert example. So here we are calculating simple interest. The inputs are principal, interest, and years. I mean, I've not really implemented the method in here, but the most important thing is we want to make sure that the principal is greater than 0, right? Obviously, when I'm talking about money, there is nothing called -1, so it should be greater than 0. So in these kind of scenarios, we use assert. So assert principal greater than 0. So if you call this method with anything less than with anything less than 0, then this assert would be invoked and it would throw an error. So I mean, there are also you can customize the message which you would want to go. So if assert principal greater than 0, and I'm saying if it's not greater than 0, then this is the message it needs to print out. So if you run this program, you would see that in the exception, in the error, it would say principal is whatever amount that you would pass. So that's basically a good example of assertion. So the most important thing is assertion should not be used to validate input data to a public method. So assertion is not a way to validate a user entered data. In those kind of situations, it's better to use an illegal argument, or you handle it and show it to the user. Asserts are more to a private methods to make sure that a particular value is within the accepted range of that particular method. And also there are features where you can disable the asserts as well. So when we are so if we want to disable the assertions, you can call it in. If we run the program passing enable as -ea as an argument, then it enables assertions. And if you pass it -da as an argument, then it would disable the assertions. Also, you can selectively enable and disable in certain packages, in certain classes, and all that kind of stuff. But the most important thing from the interview perspective for asserts is that asserts should not be used to validate user inputs. Asserts should not be used in public methods. Asserts should really be used in private methods to make sure that the assumptions which you make about that particular method are valid. In the next important question is usually reflection. So what is reflection? And oops. So I have a number of classes which are present in Java, right? For example, I have interface called list, which has a lot of methods inside this. This list interface has a list of probably 20-25 methods inside it. One of the implementations of the list interface is the array list class. This array list class has a lot of constructors and a lot of methods. If I can see, so if you look at this particular array list class, it has all these kind of, so these are oops. So these are the elements which are present in this particular class, and these are the constructors. There are 3 different constructors which are present, and there are a lot of methods which are present in this particular array list class. So if I want to dynamically get a list of, so I have this array list class, I want to find out how many member variables are present in this array list class, 1, 2, and 3. I want to do that in a program. So in a program, I want to find out how many member variables are present in this array class, or I want to find out how many constructors are there. So 1, 2, and 3. I want to write a program to find out the number of constructors which are there in the array list class, 1, 2, and 3. I want to write a program to find out how many methods are there in the array list class. So there are a number of methods in here. So if I want to programmatically do this kind of stuff, I want to know about a particular class. I want to know how a particular method has to be called in a particular class in a program. In those kind of scenarios, we use this concept called reflection. So reflection gives you details about the implementation of a particular class. So it gives me details about how many member variables are there, how many methods are there, how many constructors are there, how many of those methods are private, how many of those methods are public. So all this information you can find dynamically using this concept called reflection. Actually, reflection is a very, very simple concept. So if we look at this particular thing, so the most important thing about reflection is the input to that. So if you look at this particular thing, I am creating a class, like to do reflection, I have to create something called a class, and I'm passing what class it is, what kind of a class type is it, and I'm passing to it the class which I want to find details about. Here I want to find out details about the java.util.list class. So I want to find out, it's actually not the class but it's an interface. So I want to find out details about the list interface. I want to find out what are the different methods which are present in this interface. So this is how we do it. So I create let's look at one more example. I mean, here I want to find out the details about the array list class. So I'm doing java.util.arraylist.class it, and I want to find out I'm creating an instance list class. It's instance of this with this as the type, and to find out the constructors, there's a method called listClass.constructors. Let's see what are the other methods which are present in here. So you can get constructors, you can even get annotations. You can see it here. Oops, let's zoom down. So you can see, and you can get a lot of other details that you can see. So you can see what are declared constructors, what are the declared fields. Declared constructors, like when I create a class, it also gets a few constructors from its superclass. So declared constructors gives me only the constructors which are defined in that particular class alone. I can get the declared methods. Yeah, what are the methods which are declared in that particular thing. So there are a lot of stuff that you can get fields. What are the declared fields? What are the member variables which are present in there? What are the interfaces that it's implementing? What is the superclass of that particular class? So you can get all this information from the list class. So this is what reflection is. So reflection, to be able to do reflection on a class, all that you need to do is take the instance of the class and do a dot class on it. So dot class on it and pass it, create a class variable with it, and you can get all the So an even easier way of doing this is directly use this. So if I want to find out, if I want to do reflection on, let's say, the ArrayList class, I can also do something of this kind. So I can say, instead of creating an instance of it, I can directly do dot, and you can get information about that particular class. So you can do dot get constructors. It would print what are the constructors which are present in that particular class. You can do dot get fields. You can print all the fields which are present in that particular class, or all the member variables which are present in that particular class. Get method, you can print all the methods which are present in this particular class. So yeah, so that's what reflection is all about. Reflection is to find the internal details of this particular class. So if we look at an example, if we run the reflection examples dot get ArrayList constructors, this is the output which is printed on the console. So it prints java.util.ArrayList of int. So it's basically saying there's a constructor which accepts an integer as a parameter. That's basically the size. There's a constructor which accepts nothing as a parameter, and also there is another constructor which accepts another collection as a parameter. So these are the three constructors which are present. And if we look at what are the fields which are declared in the array list, you would see that there are these fields which are declared in the array list. If you look at the declared methods in array list, it's a big list, but these are the first methods which are printed: add method, get method, and you can add in a position. So there's an add method with a position and an object. So that's about reflection. Reflection is a very important concept, and these are typically the important things that you need to know about reflections from an interview perspective, where we are looking at the overview interview questions asked on the collection framework, like what are the basic interfaces which are present in the collection framework. Can you give a basic overview, like what are the classes which are present in there, which class implements which interface. And also we'll look at how you can use generics in a collection framework, and also we'll go ahead and see what is the collections class and what you can do with the collections class. The first class in the collection interface, is the collection interface itself. The collection interface offers different methods which will allow you to add, remove, or get a value from a list of things. So from a group of things. So what does that really mean? So you can actually have, like, this is basically all the methods which are present, all the important methods which are present in the collection interface. You can add a value, you can remove a value, or you can do a lot of stuff with this. These are the basic methods which are present in the collection interface. The first important other interface is the set interface. So the set interface actually extends the collection interface. So basically a set interface contains all the methods which are present in the collections interface. The only difference is that all the implementations of the set interface would only allow unique values. In a normal collection you can have duplicate values, but in a set you would not you are not allowed to have duplicate values. So all the values would be unique. The next important interface inside the collections hierarchy, collection framework, is list interface. List interface handles all those things where position is very important. So let's just take this list of batsmen. They are ordered in the sequence of their runs. So in this particular thing, the position is important. So I want Sachin at 0, Lara at 2, and probably Kohli somewhere down the line. It's not really 3, but somewhere down the line. So this is a list interface where we actually have everything ordered by position. So you'd be able to say, I want to remove a batsman at position 1. I want to get the batsman at position 2. I want to set the batsman at position 2 as ponting. So these are the different kinds of methods which a list interface offers. So just to recap, first we looked at the collections interface, which contains basic methods. Then we looked at the set interface, which doesn't allow duplicates, but other than that there are no new methods in the set interface. The list interface also extends collection. So in addition to whatever methods are present in the collection interface, it offers these new methods based on position. So you would be able to say, I want to get the value at a particular position. I want to set the value at a particular position to this. I want to add a value at a position. The difference between set and add is that set will change. Let's say I would do set 1 comma Kohli, then it would change the value here to Kohli. The same thing if I want to add 1 comma Kohli, then what happens is the rest of the values would be pushed outside and here Kohli would be inserted again. So that's another important thing. The list interface allows for duplicates. So in a list you can really have duplicates. If you don't want to have duplicates, then you should go for a set. So these are the most important interfaces which are present inside the collections hierarchy, which implement the collections interface. Other than that, there is a queue interface which is present, which is to store a list of values in a way you can get the last and first values easily. The last important interface is the map interface. So the map interface, most important thing, it doesn't extend the collections interface, and it offers methods which allow you to use key value pairs. So a map interface, if you look at all the methods, they are based on key value. So for this key, what is the value? For this key, what is the value? So this is what a map interface allows. So you would have methods which would all interact with these keys. So you'd be able to put key 1 comma value 1. You will be able to remove key 2. You can add key 3 comma value 3, or change the value for a particular thing. So if you look at all the particular methods which are present in the map interface, they are based on the keys. So it's a key value pair. So all the methods in the map interface would be redirected, would be in a key value related things. So in an overview, if I can summarize, the collection interface offers the basic methods. Set interface is just an extension of the collection interface, but you will not be able to store duplicates in a set. A list interface is an extension of the collection interface, and it allows methods based on position. So I'll be able to say at this position store this, at this position store that. And a map interface, on the other hand, allows you to add values based on a key value pair. So you can say this key is this value, and you'll be able to remove a key, add a key. You can get the list of keys. You can find out a lot of things based on the keys. So that's the overview of the collection interfaces. So that's the first that's the answer to the first question. What are the basic interfaces of the Java collections framework? Next, let's go on to the basic overview of the collection framework. So now that we looked at the collection classes, we'll take a look at the different classes which are present and get an overview. I'll keep it really quick. If you really want to go into the details, you can look at the other videos on this channel as well. I mean, there's a big series of playlists with videos which are just related to collections. So as we said, the collections interface is the basic. Set interface extends collection interface and so only allows duplicates. The first class which implements the set interface is hash set. Hash set is an unordered and unsorted. By unordered we mean if we implement like the order of insertion is not maintained. So if I insert a set of values, then there is no guarantee that they will be stored in the right order. So if I insert Sachin first, Dravid next, and Lara after that, there is no guarantee that I will get elements in that order back. Probably while the hash set is storing the values, Kohli is stored first, Sachin next, and Lara after that. So that's possible. So that's what is unordered. So it's unordered and unsorted. Unsorted means it doesn't sort the values. So a set only ensures that it's unique. So the basic characteristics of a set is that all values would be unique. However, a hash set is a specific implementation of a set where the elements are neither ordered nor sorted. So it's just stores things in, like a hash set just stores things. So there is no order and there is also no sorting. However, a linked hash set is one where it's ordered. That means if I insert Sachin first, Dravid next, and Kohli after that, the way they are stored also is same. So Sachin is stored first, then the next, and then the next one. So linked hash set is an ordered thing, but it's unsorted. So if I insert B first, X next, and A after that, it will store B, X, and A, and it will not be in the sorted order. Sorted order would be A, B, and X. So it would not store it in that way. It would just store it in the order of insertion. So it's, if I insert in this order, let's say I insert A first, then I insert X, then I insert B, then the way it's stored inside would also be the same, A, X, and B. In hash set, if I did a X, B insertion, the way it would be stored would be, I have no idea. It can be X, A, B, or it can even be B, A, X, whichever way it wants to store it. The hash set only ensures that the list, like the values which you insert, are present. It doesn't say anything about where they are present. In a linked hash set, they are inserted in the order of their insertion. So if I insert in this order, A first, X next, and B next, it would be A first, X next, and B next. So that's linked hash set. The tree set, however, stores it in the sorted order. So if I inserted elements in this order, then it would store it in this order. So A, B, X, that's the sorted order. So if I say A instead of X, if I inserted in A, C, B, it would store it in A, B, and C. So a tree set implements it, stores the values in a sorted order. So that's the three important classes which are present inside the set interface. The list interface, as we discussed earlier, allows based on position. The important classes which are present in the list interface are array list and vector. Array list is very basic implementation of the list. It doesn't array list, vector, linked list. Those are the important classes inside the which implement the list interface. Array list is is very basic implementation of the list. You can add a value, you can remove a value, and a lot of stuff. Vector is little bit the only difference between a vector and an array list is methods in vector are synchronized. The most important methods in vector are synchronized, which means you can use this in a multi-threaded environment, whereas array list you cannot use it in a multi-threaded environment. The other class is linked list. Linked list has each element is linked to the next one. So there is a link between each one of them, and hence in a linked list, insertion and deletion are much faster. So compared to an array list, the inserting and deleting values from a linked list is faster. However, the traversing, iterating the list is slower. So in a linked list, iterating the list is slower. So those are the important things about the list interface. The other interface which we are going to look at is the map interface. Map interface, as we discussed, allows key value pair kind of stuff. And the important implementations of the map interface are hash map, hash table, and linked hash map. Hash map stores unsorted, unordered, so no sorting and no ordering. Not the, like if I insert in one way, I might get it in another way. Hash table, however, is same as hash map except that it's synchronized. So you can use hash table in a multi-threaded environment. You cannot use hash map in a multi-threaded environment. A linked hash map has a link between one to the next element. Linked hash map maintains ordering. So the insertion order is maintained. So if I insert A, C, B, then the value should be stored in A, C, B order. So it will not store it in a sorted way. It just stores it in the order of insertion. And the other one, which is important, is the tree map. The tree map stores the keys in a ascending order. So if I insert A, C, B, I mean, I'm talking just about the keys, not the values, then it would store them as A, B, C. So those are the four important classes which are present inside the, which are implementing the map interface. If you really want to remember easily, then you can remember this way. Anything starting with a tree, any like collection hierarchy starting with a tree would store things in a sorted way. So tree map, tree set, all this store it in a sorted way. Generally, anything which starts with a hash will not guarantee ordering, neither are they sorted. So anything starting with hash, like hash map, hash table, all these kind of hash set, these don't store order, neither they are sorted. So anything started with hash would be unsorted and unordered. Anything starting with linked, on the other way, would be ordered. So when anything starts with linked, then the order in which I insert will be the order in which they will be stored. So linked hash map, linked set, all these kind of stuff, everything starting with linked, the order is maintained. However, it will not be sorted. So it will be in the order of insertion. It will not be sorted. So the three keywords are hash. Hash is unsorted, unordered. Linked. Linked is ordered but not sorted. And tree. Tree is sorted but not ordered. So I hope that's useful for you to remember this stuff. So it's a lot of classes. I know it gets confusing, but yeah, that's about the collection framework interview questions on the basic overview. Now let's just get into generics. Let's just look at a generics example. So if you look at generics, generally when I like how are generics and collections related? That's basically the question. And the way it is related is something of this kind. So if you look at this particular code, there is array list of numbers. However, there is nothing which says what type of things this array list contains. So does this array list contains a number, or does it contain a string? The only indication is from the numbers. However, from the type, I would not be able to say anything. That's where the generics come into picture. So also, let's say something dot add, I can add 5 to this. So I can, if I don't say what type an array list is, I can add a string, and I'm adding a number to it. I can add anything else to it. That's where the generics come into picture. So a generic helps us specify a specific type for each one of these. So here I'm saying new array list of integer. So I can only add integers. So if I can say numbers.add 5, numbers.add 6. But if I say numbers.add 6.0, it would give me a compilation error, because 6.0 is not an integer. It's a float, or it's a double. So this guarantees type safety. So that's the most important thing about generics. It guarantees type safety. So there are a lot of other things about generics that you need to know. You can look up the other tutorials which are present on generics in our channel. We'll move on to the next question now. What is the collections class? So is there a class called collections? So the most important thing is collection is an interface. So when I say collection is an interface. However, collections is a class. Collections is a class which has a lot of utility methods which can help you to do things on a collection. So I'm looking up now the collections class from the Java util. So it's in the Java util package. So if you look at the different methods which are present inside the collections, the most important one is the sort. So let's zoom in. The most important method inside the collections interface is the sort method. So you would be able to sort a lot of like everything using the collections interface. And the other important methods inside the collection interface are to find out the minimum, to find out the maximum, and if you want to find a list of things, or if you want to copy a list, those kind of methods are all present inside the collection You'd want to do a binary search uh, and reverse a list, shuffle a list. So these are the kinds of methods which are present inside the collections class. So collections class contains various utility methods which help you to play around with any collection. So it contains sort, binary search, it contains reverse, shuffle if you just want to put them in random order, and you would be able to have the minimum, maximum, and replace, and these kinds of methods which are present inside the collections class. Collections class is basically, you can think of it as a utility class for the collections interface. So I mean for the collection interface. So collections class is the utility interface. So it offers a lot of static methods. You can just say collections.sort and pass a collection to it. So it will ensure that it's sorted. You can say collections.reverse and those kind of stuff. So all utility methods which are related to the collections collection interface, collection framework are present in the collections class. Next, we would go on to some concept called serialization. So what is serialization? Okay, let's say I have an instance of a particular class. Let's say I have an instance of a particular class. I want to save it and reload it at a later point in time. So I want to save a particular instance of the object now, and I would want to be able to use it at a later point in time, and that's where reflection comes into picture. Usually reflection is that's where serialization comes into picture. Usually to do this kind of an activity, we would not use serialization. Serialization is not really recommended to do this. It's rather preferred that you create some XML or some some other format for storing the information, and then you can parse the XML and read the data back. Serialization is like kind of a shortcut, and it's not really recommended to do serialization when you want to transfer something between one system and another system. It's not a good practice to serialize a class and send it. So even though you can serialize a class and send it to the other system, and the other system can use it, if those two systems are Java based, then they can use it, but it's not a recommended way of exchanging information. The most important thing before learning about serialization is that it's very rarely used. So almost never. I have not seen an instance where serialization was used in my programming experience. Yeah. So serialization is a way where I can create an instance of the object. So I can, here I'm talking about the rectangle class. I can create an instance of this rectangle class with a particular value of length and breadth, and I can save it to a file on the file system. So what I can do is I can say this instance, I want to create an instance of rectangle with a value 5, with the length 5, breadth 15, and I want to create it as a file onto the file system. So that's what it enables us to do. So if you look at this is what serialization method is. So I'm creating a write object, and to which I'm passing a stream, the object output stream, and all that you need to do is call the default write object. So that's all that you need to do to be able to serialize an object. So if we look at it right now, I'm trying to serialize the rectangle object. So what I've done is I've created a new rectangle of 5, 6, and I'm writing it to the object output stream, and the name of that particular class is rectangle.serialize. So if I run this program, what happens is a file called rectangle.serialize is created. I mean, you will not be able to read that content of the file. So Java uses a specific format to write the content into that particular file. We will not be able to read it. But if like what it really stores is that there's a rectangle class with a length 5 and the breadth 6. So this is the serialization program to write content from an object. So here I'm writing content from this class into this file. So that's basically serialization. The next step is deserialization. That's basically reading from the file. So I want to read from this particular file and I want to convert it to a rectangle object. So I want to read from the rectangle dot serialized file. This is called deserializing. Deserializing is taking a file, reading the content and putting it into a object. So that's what is being done in this particular thing. So here we are doing deserialization, and you would see that once it's deserialized, you'd get length and breadth values back. So here I'm putting 5 and 6 and storing it, and here I'm reading the file and printing whatever I'm reading it. So if I run this program, you would get that this value is 5 and this is 6. So the important thing about serialization is it helps you to convert an object, an instance of a class, into a file on the file system. So you can say store this anywhere on the file system. You can send it to your friend and he can write the deserialization program to read the contents back. So serialization is mostly used in scenarios where I'm doing a lot of processing. I mean, let's say I write a program to do a lot of processing. I mean, let's say it takes 100, like it takes 5 or 6 hours to run, and let's say I only have 3 hours time right now. So what I can do is do processing for 3 hours, store the intermediate result into a file, and then once I come back, I can reload that particular file and start processing from there. I mean, it's for those kind of scenarios, and it's very rarely used for communication between different systems. So I think let's end the part 1 of this discussion on interview questions for the experienced here. In subsequent videos, we'll look at more interview questions for the experienced as well.